Hello, my dear students. The next oxo acid that we should study is the peroxomonosulfuric acid H2SO5. This peroxomonosulfuric acid, if we look at, sulfur is bonded with two oxygen with double bond. The sulfur is bonded with oxygen and hydrogen, that is a single bond. And here you have SOOH. So these O are bonded with each other, which is a peroxide bond, and that is why these two oxygen, they have -1 oxidation state in them. So you have S double bond O1, you have S bond OH1, and you have SOOH1. These both the acids, when they, these both hydrogen, when they are dissociate, they gives 2H plus ion, and that is why it is dibasic in nature. Oxidation state of sulfur in H2SO5, if we calculate 2 into H, 1 into S, 2 into O, which are the peroxide oxide, and 3 into O, which are the oxide. So 2 into O, you will, like here we will put -1 for this two oxygen, and here -2 for this three oxygen. You can see here this 1, 2 and 3 oxygens are -2, whereas these two oxygens are -1. So by putting these values, we can find out the oxidation state of sulfur here in H2SO5 is +6. Now we have the next one to study, which is known as the H2S2O5, which is known as the disulfurous acid. Here in H2S2O5, you can see that one of the sulfur has got a lone pair, whereas the another sulfur is bonded with 3 oxygen, whereas this sulfur is bonded with 2 oxygen. So you can see that S double bond O are 3, S bond OH is 2. So we can say it is a dibasic acid. These two hydrogen, they are dissociate into water to produce this dibasic acid. The oxidation state of sulfur here, you can find for sulfur by doing the required calculation, is +4. So due to presence of a one lone pair and +4 oxidation state, there is a possibility of reducing nature for this oxo acid, as well as the possibility of disproportionation reaction, because +4 can easily go +6, or +4 can go into the lower oxidation state -2, or it can go to the zero oxidation state of sulfur, and that is why this acid can disproportionate easily. Then we have the next kind of acid, which is known as H2SXO6, where X is equal to the value of 2 to 5. So it is known as the polythionic acid. Here you can see that the terminal S are bonded with 3 oxygen, where 2 S double bond O and 1 SOH. The same you can see. And in between you have S are bonded with this S, which is N. Here your N is equal to 0 to 3, or N is equal to X minus 2. So you can easily have S double bond O4 and S bond OH2. The number of S and S bond is not clearly fixed. So here we can have H2S2O6, where you have single S bond S. Here you may have H2S3O6, where you have 2 S bond S. When you have H2S4O6, you have 3 S bond S. And if you have H2S5O6, then you have 4 S bond S. So you can easily understand the structure of this is very important. H2S4O6, which we have studied into the 11th standard. This ion S4O6 minus 2 is known as tetrathionate ion, and you can see the structure of this tetrathionate ion, where these two sulfur, they are supposed to have zero oxidation state, whereas these two sulfurs, they have the +5 oxidation state, and that is why sulfur in H2S2O5, the sulfur in H2S2O6, this sulfur is believed to be having the +5 oxidation state. I'm sorry, I'm talking about this H2S4O6. Here these two sulfurs are having the zero oxidation state, where these two sulfurs are +5 and +5, you can understand. So the oxidation state of sulfur in tetrathionic acid is +5, you can easily understand. Then we have the next oxo acid, which is known as the sulfuric acid. In sulfuric acid, you can see that sulfur is bonded with 2 oxygen with the double bond, whereas it has 2 SOH bond, and that is why it is dibasic in nature. and the oxidation state of sulfur in sulfuric acid is +6. Then we have the next one, which is known as the pyrosulfuric acid. This pyrosulfuric acid is also known as oleum or fuming sulfuric acid. Here you can see the structure of pyrosulfuric acid H2S2O7. The extra kind of bond which you find new is S bond O bond S. So here you have S bond O4. You can see 1, 2, 3, 4. Then you have S bond O bond S, which is 1. And then you have 2 S bond OH. That is for this acid is a diabasic acid. And the oxidation state of sulfur here in H2S2O8 or oleum is found to be +6 oxidation state. So oxidation state of sulfur in H2S2O7 is +6. Oleum or pyrosulfuric acid is even called the fuming sulfuric acid. Then we have the last one, which is known as the peroxodisulfuric acid H2S2O8. Here you can see that between these two sulfur there are two oxygen present. These two oxygen make a peroxide bond, and that is why the oxidation state of this oxygen is -1 and -1. So you can see here you have S double bond O 4, O bond O, there is one peroxide bond, and you have S bond O bond O H, that is determining the basicity. So this H2S2O8 is even diabasic in nature. Oxidation state of sulfur in H2S2O8, we can easily understand that these two oxygen which are having the -1 oxidation state due to the peroxide bond, and these 6 oxygens they have the -2 oxidation state due to the oxides. And ultimately if we calculate all these things, we find that the oxidation state of sulfur into H2S2O7, sorry, into H2S2O8, which is also known as the peroxodisulfuric acid, is +6. In the next period, we will study about the sulfuric acid, my dear students. I hope you are enjoying your studies. Happy learning.